Hey Austin, how's it going, dude? Welcome in. All right. All right. Sweet. Sweet. All right. Welcome back, everybody. Hope you're having a wonderful day so far. Appreciate you for joining me again. Sorry for coming on a little bit later tonight. I'm still on my come down, I guess, from releasing the project. Kind of more not taking a back seat, but just kind of just recharging my batteries and whatnot before we get into our next project and whatnot. We were really grinding quite hard for that project, putting in a lot of hours to complete and get the bones of it out and at least getting a working product and proof of concept out there, which was our goal. So I'm gonna keep going here. I'm just a little bit tired. I'm also building product at work. Having to put in some hours in there, extra hours to just do that and whatnot. So anyways, plus it just now turned dark at 8:45 p.m. It's still a little bit light outside, but it's just now turning dark at 8:45 p.m. So the time the light it kind of is messing with me. I feel like I have more time when I don't. Anyways, thank you guys for being here and joining me. This is the Leet Code Daily today, 2616. Oh boy. So this one says you are given a zero index integer array of numbers and an integer p. Find p pairs of indices of numbers such that the maximum difference amongst all the pairs is minimized. Find p number of pairs of indices of numbers such that the maximum difference amongst all the pairs is minimized. Also, ensure that no index appears more than once amongst the pairs. Note for that a pair of the element at the index I and j, the difference between the I minus j, where x. So for here, and this return the minimum maximum difference from among all. Okay, so let's look at an example here. Hey, Mr. Tim, what's going on, dude? Hey, Mon. All right, numbers. We have an array of numbers here, and we have a p of 2. So we need to find two pairs of indices. The first pair is formed from indices 1 and 4, and the second pair is formed from the indices 2 and 5. The maximum difference, so p is 2. So indices 1 and 4. And then in indices 2 and indices 5. What? What is this asking? I don't even know what this is asking. You are given a 0 and a... Find p pairs of indices of numbers such that the maximum difference amongst all the pairs is minimized. What is this question even? See, sometimes these questions they're really tricky to. The wording on them is really annoying. I have not looked into Java at all. I don't know anything about it. Sorry, dude. All right, maybe we gotta ease into it here. I was thinking that Tim. I was thinking that Tim. You know, kind of just grinding away on some Leet code problems, and then maybe like start shelling out some applications now that we have our project kind of done. Counting bits. I need to get better at these guys. You were given an integer n. Return an array answer of length n plus 1 such that for each I, where index, okay, is the number of ones in the binary representation of I. Oh, okay. So we're given an n. We need to return an array, and the array is going to contain a length 1 greater than n. And then for each indice within this answer array is the number of ones in the binary representation of the indice. Okay. So if I'm understanding this correctly, here we are with some more strange wording-ish. Okay, so if I'm understanding this correctly, is that we're given a number, right? And because n is 2, we just are going to give a 0-indexed array, 1 greater than n, right? So that's why we have a length of 3 here and a length of 6. And because the numerical values up into that range of n, we convert to binaries, and we detect how many ones are within, right? Okay, interesting. I'm always bad at these binary ones. I'm not the best at binary notation and numbers and stuff yet. I need to get better at that for sure. Like our different base conversions and stuff like that. Okay, so we need to create a answer list, right? Where we need to write okay, so can we say like for I in the range of n plus 1, right? We're going to loop over n plus 1 times and convert I to its binary representation. So we're going to say binary is equal to bin I. Right? And then, so right here, I'm just going to print binary. Let's see what we get here on just a print statement. Okay, so we get the 0 B's, right? That's right, the binary gives you the 0 B. Now, I want to print the type of binary. So these are strs, binary strings, okay. So let me go ahead. What's an efficient way, like rather than having to loop like again through the string to identify how many ones there are, right? Is there a way that we can so let's see, is there like a pattern maybe? Let's look at these examples. So here, right, 0, well, this has 1 1. The 2 converted is 1 0, which has 1 1 in it. And the 3 is 1 1. The 4 is 100. Sorry, I don't have the music on right now, Tim. My headphones are dead. I'm just waiting for them to charge. I was um, listening to my podcast while I was eating my food. Okay, so right, so I don't want to have to loop over the string again and try to find. So does the bin function? I forgot. I always forget about this. It has like this additional parameter. Okay. Right, so we need to slice off the first two characters. My bad. So that'll slice off the first two characters. And now, but the thing is I don't want to. I don't want to have to loop again. Is there any way that I can use previous knowledge from the past number lookups somehow? 1 1 2 1 2. Hey Douglas, how's it going, dude? Welcome back in. I appreciate you for joining me again. So I'm trying to figure out, like, I definitely like know how to do it, right? But I'm trying to see if there is a way to, rather than looping through this string again. I mean, I could just say like, isn't there an all function in Python? The all function in Python built in, it takes an iterable. Oh, it's true. Iterates through the iterable. So the all just does the iteration for us. What do you guys think? Is there a way that we can use the previous numbers to kind of build the next one? I'm just not super familiar with like any like binary patterns. It's very easy to come up with a solution in the wrong time and log in. Linear on a single pass. You do it without any built-in functions. Single pass. Right, I don't want to have to then loop through this binary string to count ones, right? No. We'll come back to that one. I think I know how to solve that one. I did some research onto that one. We'll save that one here. Interesting. Let me look up like binary number patterns. Binary code patterns are sequences of ones and zeros. hold on. What if I do this? Let's try this. Let's int convert the number. No, because my thinking was, well, trailing zero or leading zero, trailing zeros, no, those will stay. Well, could we use like maybe another binary operator comparing like a two-pointer approach, comparing numbers as I go? So let's see, if I used like binary and, so if I have n, which is 5, could I use like, could I set these numbers against one another? So on a 0, we know we bin and we get 0. We bin the 1, we get 0, 1. Where's my headphones at? What's the volume? Okay. I only have 2% on the case. We need to keep going. Okay. Could I take this? Will put the 0 against first. So then we'll cancel out those. Ah, this is interesting. Interesting. Okay, so how can we do this in a single pass? Well, I mean, let's at least like, let's go like this. For char in binary 2. For we're gonna take a count here. 0. If it's 1. And else at the end we're going to so this is the n log n approach they're talking about, I think. Okay, never mind. I'm trolling. There we go. When you convert it to an integer. Oh, yeah, we can't. We're trying to iterate. We can't iterate over an integer. Ding dong. So we need to say quote 1. Right. So this is the n log n approach I think that they're talking about here. But can we do it in a single pass without having to have the inner loop? Yeah. See, this is the Right. So can I do it now? How, is there a way like to use the previous value, right, or some value within the range using like an alternate pointer, whether it be at the end or to the right or somewhere, to compare values along the way and then, right, and report out the counts via like a length call, right? So if you say like 101 divided by, hmm. Hey Codeverse, how's it going, dude? Yeah, my projects are built in that. My Spectro Sim we built in React.js, and my website we built in React as well. Interesting. I'm thinking I'm dumb. I'm not sure I understand the question. Does it simply write from scratch function to convert number to binary? Okay, so what this one is asking us to do, right? We've solved this, but we've solved it using the n log n approach. Now it wants us to try to use it with a O of n pass. So it's really easy to solve with O of n, O log n, O n log n, because all you do is just convert the number to its binary representation. You kind of slice off of the first two characters, right? Which are the 0b binary representation, and then you just loop over that value and count the ones, right? But this is this internested loop causing the additional time to take place. So we're initially looping over n values, and then we're looping over log n values because each value gets smaller by, yeah. Did you like working with React? I'm studying Python right now. I'm considering to go for that next. Yeah, it was a lot of fun to actually kind of get my Python like work and like ideas like onto a web kind of thing. And I used Python when I built those projects with Fast API to have my backend and host it. So, and then what we do is you just, right, you just have an index I that you're tracking through the range of this n value they're giving you, and then you're just plopping in the count of all the ones for that I binary converted. So like 0 converted to binary is 0. There's 0 ones in there, so 0 got to answer attached to answer appended. 1 converted to binary is 1. There's 1 1 in that binary number, so 1 got appended there. 2 gets converted to binary as 1 0. There's 1 1 and 1 0, so 1 got appended there. Because I like to learn myself. All right, so let's speak a hint here. You should make use of what you produced already. Yeah, I know that. Okay, so that's exactly. So we're on the right track. We're on the right track in thinking that we need to use the previously produced results. Oh, wait, we can like build binary numbers, right? So 1 0 is 1 0. 1 1 is 1 1. I don't know. Make use of what you have. Divide the numbers in ranges like 2 to 3, 4 to 7, 5 to 8, 15, so on, and try to generate new ranges from the previous. Oh, look at that. Even numbers, odd numbers. There is a little trick. So even numbers have 1, odd numbers have more than 1 potentially. The number into ranges like okay, so he's using a map here. He's mapping the int. Forgot what this one applies a given function to each item. Map function in Python applies a given function to each item of an iterable and returns an iterator that yields the transformed items on demand. The map function is used to apply functions to every item of an iterable like a list or tuple and returns a map object which is an iterator. So we convert every value of s to an integer and then print the list. Okay. Okay, so what he does is he converts the binary string into an integer. And then you sum interesting. So you just call a sum on the integer. So if you convert everything to a binary string, then you sum binary. Let's print this. So how does he sum? So he says you take bin at I, we have our for loop here. Okay, so you take the bin, you slice off the first two characters, you convert it to an int. Oh. So by applying the map function, to the map just converts all those. By applying the map function to the integer that returns a, and then you can sum. Okay, so if I instead, let me do this. Let me map I'm a little bit confused. So you map int and the binary string, and then let me print, in this case, binary here. This gives me an iterator of map objects, 3 map objects. Okay, so then he just calls a sum on the map object, the iterable object, and then you do answer dot append this, then you just return answer here. But this one's even slower than my other one. Okay, interesting. So because he's still doing the sum function across this iterable, it's still having to sum every value, doing that inner loop. So this still isn't the best approach here. Interesting. So we've been able to solve it with the inner loops, right? He's just using this sum thing, this map, and summing the map rather than what I did before, which was just detecting first string ones throughout with a loop, right? Here. Interesting. Hey, Bizwine, how's it going, dude? Unknown, how's it going? What sort of things are coming in? How many days has it been since you started learning? I've been learning teaching myself pretty much almost every day for about a year. Thanks for coming in. All right. So I'm gonna, let's go to the orb here. Let's go to the orb here. Okay. Here is my current passing but non-optimized solution for Leet code 338. I am trying to figure out a way to do this in O of n time I know that I need to reference the already existing data. I am just not sure how and in how. Do not show me any code, but can you coach me in learning the concept I need to solve and reach my goal? You got a working baseline, and now you're focused on improving it intelligently using pattern recognition and data reuse. Let's break this down as a coach would guide an athlete. Okay, chill out, Chappie. You're looping from 0 to n. You're manually converting each number to binary and counting the ones, which takes O of log n per number due to the string conversion and scanning. The total takes n log n. The goal is to get this to O log n. Core insight for optimization. To reach O log n, you need to avoid doing repeated work. So we've known that we needed to use the pre-existing computations, but in what way? No repeated conversions, no rescanning every number individually. Leverage previous results, compute the next one. What changes when you increment a number? What does bin I look like compared to bin I minus 1? Can you spot a pattern in how the numbers of ones changes between I and I floored interdivision by 2? Okay, so if I floor 5 by 2, I just add a 1. If I floor, add a 0. If I floor 3 by 2, I just add a 1. Okay, so hold on. I think I get it. Wait. So if I floor an even I add a 0 to the end of the most recent even, and if I floor an odd, I add a 1 to the end of the most recent odd. You're really close to a powerful insight. Let's refine your observation. If I floor an even, I added 0 to the end of the most recent even. You're kind of describing how binary shift works. Where you just add a 0 to the end and the ones go away. Bit shifting intuition. When you do I floor 2, you're shifting a binary representation of I 1 bit to the right. Right, so moves it down and adds a 0 to the end. The least significant bit. Right, this guy. When I floor 2, you remove the least significant bit, the ones bit. And now this becomes the ones bit and this becomes the tens bit. Whereas this was the hundreds bit. Okay. 6 in binary is 110. You've lopped off the 2. The number of ones in i's is derived from the number of ones in i's. The number of ones in I can be derived from the number of ones in I floored by 2 plus 0 if I is even. Okay. So item is the same as right shift. So if I equals 0, the binary is 0. If I is 1, the binary is 1, 0, 0. 1, total number of bits is 1. 2 in binary is 1, 0. Interdivision I is equal to 1. The number of bits what's bits in I floor 2? Bits in I floor 2. New answer from known ones. The keys seem to be before. Let's think. Okay, let me put on my headphones here so I can hear chat. Alrighty. Where are you? Where'd chat go?
Show's also brought to you.
The church, what's happening now? It's one of funny podcasts I listen to. From back in the day. Okay, let's see here. Let's get some. All right, we're back in biz. Okay. Interesting. So we just need to binary the number of I. So can I have a helper function? So I'll say helper given n. I'm going to say if n is, so I would write this function recursively. You're correctly seeing this odd and even, you know, bottom up recursive relationship between. So when I floor 5 down, I get 2. The bits that are in
This
here.
way and says you know bin and count function and life.
You start to feel click. 2 here. The bits in I floor 2. So what does this column represent? Bits in I floor 2. There's 1 bit in I floor 2. I floor 2 is equal to 2. 2 has 2 bits. Is there more? Multiplies 4. Total bits. Oh, because we already found the one previously. Okay. Let's see here. If I want to, if n is equal to so would I write this recursively then? Even though recursive evaluator expressing the most optimal in this case, we just end up computers. Okay, so we'll say for I in the range of n plus 1, we want to, we have the answer here, which is an array. We want to go here and say that I floored by 2 is 2. So I need to map say that map at I is equal to, we're going to save the value in the map with key at I, I floored by 2 plus my modulo by 2? Is that what I'm looking for? No, we don't need the map because we're going to go previously get the amount of ones found in the previous answer. So then this will go, we need to access I at the index floored by 2 in answer. Right, and then add to that I modulo by 2 to detect the even, whether we add a 0 or a 1 to the end. And if you add a 0, it doesn't do anything. If you add a 1, it increases the count, right? So we're out of bounds. So if I just go to n 0. Answer index I multiplied by 2. So it's trying to access answer at 0, but there's nothing there. Right? It's trying to access something here. So do I need to start this array with a 0 in here? So that there is a value at least in here? Or do I say this is going to be like times? Right, you set zeros right away in there. Aha. So then maybe I can just can I just start it off with a 0 in there, or do I have to preset all? Okay, you have to preset all. Okay, I think let's see. Is there any other improvements we can make here? Nice. You're adding 1 if it's odd, else it's 0. You're pre-allocating the array for speed. Okay. So what we did is we pre-built the array full of zeros. We then are going to access the answer at that current array is going to be equal to, we're going to override the value to be equal to a value that is, predated in the array, and then add on to that, which will give us a count of a number of ones, right? Add on to that the 0 or 1, depending on if that is even or odd at this point in time, if I is even or odd. Interesting. So I knew there was some little binary trick to our pattern, right? We definitely detected it right away. We solved it. We had to get a little bit of help for this portion, but we solved it with the O and log n approach fairly quickly. Nice. Yeah, we saw this was our slower approach here, and then we optimized with this one. Interesting. Okay, let's go take a crack at that other problem though. What was it called? Parentheses something? Valid parentheses, generate parentheses. Okay, so I think I know how to solve this one. I did some researching on backtracking, and we were pretty close yesterday. We were pretty close. So I looked at some example problems, and I think we can do this one. Let's try it. And then we'll probably call it there. It's a little bit shorter stream. I came on later. I had a little bit later day at work today, and I got some dinner and was just kind of chilling, hanging out, and kind of recharging my batteries here. So appreciate you guys for hanging with me. We're going to be grinding Leet code for the next couple of days. Finishing up I have a couple of bugs I need to fix on our SpectroSim. I need to make a video for SpectroSim and put it up to our portfolio. And then once it's on our portfolio is when we can revise our resume and then start sending out dev applications maybe. So hopefully by the end of June or something we can start getting these dev applications out and maybe seeing if we can even have a shot, you guys. I don't know. It's going to be interesting. I'm kind of scared. What do you guys think? Okay, so for this one, we were on the right track yesterday. We definitely need our helper function. Right? That's something that all of these had, is this helper function.
Mohan
Now
says I'm a do with you.
nice. So we have this helper function, and we were right yesterday, and I think needing to track the amount of lefts, the amount of right or opened, closed, and then the we'll need to track, in addition to that, the total number remaining, right? So if I say def helper, I'm going to call helper. It's going to say open, close.
Mohan says, Mike Israel cook my
Total.
home country. Do you follow news?
Yeah, I heard about some of that news stuff that's going on. I don't really know too much about those kind of conflicts, though. I tend to stay out of those kind of more sensitive topics. It's not really my place to being just a white American guy. Okay, def helper open close total. So my base case, right, my base case is if the length, no, we don't want total. This is going to be our string, right? So if our length of our string becomes equal to n, we're going to return. No, we're going to string dot.
Mohan says my parents just left a place they boomed like 3H before.
Result dot append the string here. Oh wow, they got really lucky then. That's insane. Oh, you're from Iran, Mahan? When was the last time you visited there? So if the length of the string is equal to n, we're going to result that append the string. Okay? So that's our base case. We've built a successful string. Okay? We're going to call... Right, there's some stuff that we have to look out for. We cannot...
Says, yeah, like 3 years ago when I left.
Oh, wow. Okay, so we need to make sure that a open parenthesis is placed right in an open parenthesis is valid to, this is not n, sorry, this is going to be 2 times n. Right? So we'll say if the amount of open...
Mohan says, oh wow, permutations, right?
So if opened less than n, right? Because the amount of opened, the opened is the count. If the amount of opened parentheses is less than n, we can place an open. So we're going to call our helper function given opened plus 1, right? We added another, we're going to add another opened, the current amount of closed, and the string plus equals to an open parenthesis. Right? So if the amount of open parentheses is less than n, we're going to place an open parenthesis recursively, meaning that we have the valid option to place it. So then, if now we need to place the closed string. So you cannot place a closed string. What's the condition on the closed string? You can't place a closed string if you have less open strings than you do closed strings, right? Because you can only place a closed string if you have more open strings than you do closed strings, because there is an unpaired open string, an open parenthesis, right? Let's say you have 3 open parentheses and 2 closed. Well, one of the open parentheses is open still. Okay, so if closed less than opened,
Mohan says maybe use stack for that purpose, like the famous stack practice question.
Then we're going to call helper on the current opened count.
Scaristic says, Mike, what's the name of the data structures book that you used to read?
That I used to read? Oh, brutal. Calling me out. Calling me out. Come on, man. Don't do me like that. Come on. That I used to read. DSA in Python, my friend. It's in my Discord. Everything is in my Discord, you guys. So if you guys are looking for any resource that I've used on stream, whether it be reading, courses, math, anything, check it out in my Discord here. You can also participate and sign up for the upcoming whackathon that we're going to do soon.
Miss Wayan says backtracking is the ADV version of brute force.
So we have, right, DSA in Python here. What is this sticker? Reacted by Angela. Nice.
Mohan says, Mike, what was the course you used to take in calculus?
All right, now we're pushing it. Now we're pushing it, boys. I know I need to keep doing on. I haven't done calculus in like 2 weeks, you guys. Dude, I could have been done with like unit 2 by now. But on the other hand, I probably wouldn't have been done with SpectroSim. So, you know, there's trade-offs to everything, you guys. I probably wouldn't have been done with my project. So, okay, so if the closed is less than opened, we're going to call opened, increase the closed, and add onto our string a closed parenthesis. So then I'm going to call result equals to a blank list. I'm going to call helper on 0, 0, and a blank string. And I'm going to return result. I'm pretty sure this is it. This looks really familiar. This looks really close to those other problems that I was looking at and the examples for backtracking. I watched that redheaded guy on YouTube that does all the Python code videos. and then me and ChatGPT, we had a conversation. While I was driving, I threw on the voice mode, and like as if you're just having like a talking on the phone. That's something that I think is really underrated about ChatGPT, you guys, is you can throw on the push to talk and or basically have like a verbal conversation as if like so like on my commute, what I'll do is that like I will prompt I'll talk with
Says
ChatGPT
he
for
wants
like
to go.
I'll prompt ChatGPT for like um, just my ideas, like talk over projects, like upcoming, scheduling, and like it'll just help me kind of work through my ideas and kind of align them, especially while I have that 50 minutes or so or hour to commute to work to and from. So um, I do that quite often. I highly suggest. Okay, so I think with this will work. Okay, ready? Let's go. Let's freaking go. Call me the backtracker. Call me the backtracker. No, okay, so I definitely, I made that look a little easier than it was. I spent about an hour and a half yesterday doing a bunch of attempts trying to solve this, overcomplicating it, but I was along the right track. I was tracking open and closed, but I was using a sort of a stack data structure when I can infer that open and closed, I can use the open and closed counts kind of creatively to do that for me rather than using a stack or whatnot. And then yeah, so this is nice. Okay, this makes a lot more sense. This makes a lot more sense. Look at us. Look at this. Let's go. Woo!
Mohan says also UALR tried stack.
Yeah, I tried the stack yesterday. I mean, it definitely like would work, right? But it just was not like as optimal as like we were getting kind of the right mindset. Like we were walking through it on the whiteboard and adding
Nug says
the
he
open
should fix
parentheses
phone
to the
number
stack.
problem now.
Yeah, we'll have to do some more backtracking problems to make me really think if I'm the backtracker. Oh gosh, which one's the phone problem? Phone number problem.
Mohan says but since it's recursion, you can also implement stack but so long it.
Yeah. What's the phone number? Let's see, phone. This one, valid phone numbers. Maximize difference between, no, that's the daily. Design phone number directory, phone number prefix, reformat. Letter combinations. Oh, this is a bash.
Nug says letter combinations of a phone number.
Letter combos.
Mohan says check 79 might.
Phone. Letter combinations of a phone number.
Mohan says little harder than what you did now. Nug says I think it's easier but IDK.
Oh, look at this Motorola. Motorola. Given a string containing digits from 2 to 9 inclusive, so 2, 3, 4. Don't have 1? Return all possible letter combinations that the number could represent. Return the answer in any order.
Nug says yeah word search ain't easy lol.
Okay. Let's see. Okay, so do we need to make a map of... Do I need to make a map, a structure of these? 6, 7, 8, 9.
This way and says fact. Stack is so good. Ability to make any recursive to iterative.
Yeah, we were trying the iterative stack approach yesterday. But we were kind of blending the two. We weren't differentiating between iterative and just a stack. We were kind of, we weren't really, we were getting it, but we weren't really getting it. So this is going to be a list of quote A. Do I really have to do this for all of these? Why did it do this? Why didn't it just give me this? This is frustrating. A, B, C, E. Oh my gosh, can I spell A, B, C, D, E, F, G, H, I, J, K, L, K,
This
J.
way says true faced that frustrating thing.
Through M, N, O. They couldn't really give us the map. That's like really annoying. JK, yeah. This is gonna be P, Q, R, S, and then we have T, U, V,
Mohan says nuts how hard is 1004.
Mahan, I saw your message on Discord. Sorry, dude. I've just been really busy at work, and I come back and I eat, and I get on the stream, and I get off stream, and I go to bed. I haven't. I will look at your thing, dude. I promise. My bad. I want to actually give you the attention it deserves. Like, give you a good look over. So. Okay, so now we have this. Okay. So if you have the number of digits, okay, so the number of digits, you can only have a number of digits proportional to digits, right? So if you have the length of digits is going to be the length of the number of letters that you can have, okay? So
Mohan says, it's cool my guy, I know you are busy. Just wanted to follow up but no push.
So do I need to put the map inside my recursive? I think so.
This way and says I advise you to make string that key number.
Make the string a key number. Well, can't you only have keys as strings? Can keys be integers? I didn't think they could. No, they can't be because you can't. It'd be like indexing. You have to have keys as strings. So if I have def helper, this is going to take in the current string.
Nug says, Mohan Norhas in Alipur I didn't find it particularly difficult.
Did the TTS say your last name right? Last name right?
Mohan says so you calling me dumb rude.
Okay, so we have M. We say if length of the string is equal to the digits, to the length of digits. Then we're going to do results append string. Okay, if okay, so then we say okay, so then if I can give it a string, I want to so I want to call helper so the thing is do I want to call the helper function okay, so if the length of the string is equal to the length of the digits, then we're done. We have we're done with the combo. I need to call the helper function I need to update string. So I need to say string plus so do I use a loop here and say for digit in digits I need to call helper on this gives me the digits so this to go off of. I'll go helper m index digit string plus m index digit. That'll add for digit in digits helper string plus m. Why do I suck? Come on. I just need to call helper for every character. The thing is I don't. It's interesting because I'm trying to get the
Fort
key of.
Murin says, hey, just came back. What's going
How's
on?
it going, dude? I'm trying to solve this one here. We're gonna call helper on the string, but we're gonna add to it a digit that's within the mapping of M. Right now, this is going to add a list to this string, and that's not going to work.
Fort Murin says, is it medium problem or easy?
This one's a medium here, it looks like. Man. If the length of the string is equal to the length of digits, we append the result and we return. We're done. Okay, but how can I call recursively
Justin says, I would have already turned to GPT for help, haha.
Yeah, I'm contemplating, Justin. I'm contemplating. Oh, holding strong. So if we need to call recursively the helper function on every
Says,
digit.
try drawing a decision tree.
Okay, try it out. So if we have quote 2, 3, we're going to access quote 2. We can either take A, B, or C.
Fort Murin says,
Oh, I
ask
got it. I
GPT.
got it. I 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 got it. No, I don't got it. So we call, and then this can either get attached to it either a D, E, or F. So I need to concatenate helper
Mahan says, I'm fancy permutation tree.
So I need to concatenate how can I get the next one though?
Mahan says, Mike on some good meat.
What? How can I get the next one? So A, B, or C.
Fort Murin says, why not append instead of concatenate?
So if I'm trying to, I start on the 2, and then these are the mappings to the 3. So I go. But what about these ones that have 4? Ah. So how can I combine helper string? I need the string. Going to increase. Well, could I get, if I have the map here, could I use a function to get the values and then pass in the remaining values and pop them off as I go? Right, so what if I put the map out here? Can I reference the map from this inner function? I don't know. I can get digits. So then can I say helper, so you have a string, so you have like a, well, you can have a really long number though. Okay, so how, my base case is if I have an A and a D together. Okay, I met my base case, that'll get shipped off. Okay, but how can I go into the map and get out the A, but then move forward? Okay, so we're going to say we were to append the results. Oh, hold on. If length is string 0, I want to take helper. I don't want to do it. No, like. Ugh! So we have a mapping. Append the results. How can I concat this together? So I say like.
Fort Murin says why gross medium is actually intensive problem.
So then we say M index. I have to access every digit in the string though. These are the digits given.
Ford Murin says, I am solving with you. Let's see who get faster.
I'm about done here for tonight. If we have to come back tomorrow, we'll come back tomorrow. So why can't I... So if the length... So I'm going to call the digit of the... I'm going to go into the mapping and go into what key? Well, I need to get the key of the digits so we have to recursively call it on every character though. It's like for char, for like integer in digits, right? We're accessing the integer. Now we're getting the 2 and the 3.
Nut says, did your algo book go through backtracking?
I don't remember it, no. It might have, maybe I just missed it. So now for I in digits, I need to call the recursive function helper. But is there something else I should be tracking in the string? No, the string is what's gaining. So do I need to have like a starting point, like an index, basically, as well to pass into? Right? I'm going to say helper string plus m at for char in m. No, wait, we're going to stick on an A. And then from the A, I'm going to go stick on a D, or an E, or an F. I just don't know what to do with the list. Like, how can I move from one character to another with a list within the map? to be m mapped to digits at that index.
Nut says you're on the right track with the loop. Nut says you have to loop through each possible letter of a digit.
So m digits index. M index digits index. This will give us the 2 and the 3 values. I want to concatenate I don't know, dude. This sucks. I hate Leet code. I should just keep building projects. This is honestly so annoying. This gives me the list. Helper. String plus not this list. Index. For each letter.
Ford Murin says, bro, can you solve container with most water problem? It's medium. I want to see your thought process for it because it wrote
Helper
the
string
worst
plus
code for
m
it.
digits. For char in m. For a char, we're going to call it helper. Maybe? Maybe?
Nug says ye very close.
Oh, okay. Build a new string plus letter and recurse with the next index. So one. Char. So this is out of air. So this index is going to be first 0, which is going to go to the 0 of digits. Get the 2, map to 2, get every char. To map to digits.
Nug says I think you need to make sure you exit from the if statement. Nug says need to return.
Let's go. Spazzing out. Ah! My dog's looking at me like, what is going on? Okay. Okay, so I was right. We did have to loop over the list. Right? I was like, I was stuck. I was like, what do I do with this list object? Like, how do I get every value out of there? So you can, I've just never done a loop within a recursive function before. So I was like, I didn't know if that was like allowed or not.
Nug says, nice, good job.
I didn't know. I just didn't. I wasn't. I see some. A lot of the times I second guess myself because I don't know if certain things are allowed. Honestly, I really chalk it up to like a lack of just knowledge and education on the actual maybe algorithm itself, or the type of not overarching algorithm, but like recursion, like properties of recursion. I just didn't know if it was allowed to really use like a for loop in a recursion.
Hard for me also. Analysis it.
Yeah, so I mean, I got the first part really easily, right? This part was really easy. This part was really easy. And then obviously getting the map. I just didn't know how to extract out each character and then when to recurse on that call. So what I had to do is I was right about adding an index here to track as well.
Tejas says nice. I respect the grind.
Allowed in just like in terms of like time, because sometimes I think that with these recursive algorithms, it's probably unrelated, but whenever I just deal with recursion, I always try to not get that that error of like that infinite steps or whatever. Plus, when I'm calling like a recursive step and having a loop inside, it just kind of throws like it kind of like throws like a red flag just in my mind of being like, oh, I'm recursing with a loop inside, so I'm adding even more time. It's just kind of like a little bit of like a psychological kind of throw, I think. Right? And so I had to add this index tracker to be able to not only access the index here, but access the index of the char. Or sorry, no, we're accessing the char with the loop. We're using the index to access this here, correlating to the index of the digit. Let's show it our boom. Boom is right. And correct. Let's break down this approach. Good recursive hygiene. Pro level follow-up. Counting how many combinations would be generated for n digits. What's the branching factor? Ooh. All right, you guys. We solved 3 today. Good little Leet code session. 3 problems, not bad. We solved 76 problems, so maybe by the end of like next week we'll be at like 100. Not bad, not bad. All right, you guys. Thank you guys so much for being here and hanging out with me. I started to cut this one a little bit shorter. We only did an hour and 50 today rather than normal like our 2.5. I was a little bit late today. Just had a little bit of later day at work and got some dinner, kind of recharging my batteries and everything. Yeah, I saw some examples along that one as well. We'll have to give that one a shot next to solidify this one. Yeah, Mahan's been waiting for us to solve the Sudoku one, so now that we've got backtracking, we'll have to go give that one another go. I did try it at first, and I couldn't do it. All right, you guys. Thank you guys so much for being here. I stream every single day around 7 p.m. PST. I will try my best to be here on time tomorrow. This weekend, I am having a little bit of a change of schedule. I know my schedule's been a little bit all over the place. It is summertime, so things and more events are starting to happen. Like I went to that concert a few days ago and missed a stream, and so this Saturday I am going up to the lake to just my family is actually going to be there in a nearby lake, so I'm gonna meet them there and have fun and spend the day with them. So if I don't get a stream in on Saturday, I do apologize. Truly, I will try my best to get a stream in at least sometime, somehow, some way to do something on Saturday. But I don't get to see my family that often as we live in different states. So whenever they're in the ballpark, I do try to make an effort to go and hang out with them. You gotta keep things in what's important. The code and the Leet code will always be there, but so your family members aren't always there. So, keep that in mind. I also recently watched this Bill Gates commencement speech where he talked about how something that he wished he learned when he was younger, building Microsoft, was that vacations are okay. Now it's kind of interesting. I wonder if that's in hindsight he says that. But in reality, I wonder if he would have taken vacations, Bill Gates, during the core development of Microsoft. Nice. Yeah, that was a long time ago. That's when we were first learning it. It was really tricky for me to wrap my head around at first. I'm still wrapping my head around it. But what was I talking about? I completely lost my train of thought.
Wayne says now this recursive problem. Now you will be.
What was I talking about before? Oh, Bill Gates. I'm wondering if he would have taken that advice of his older self and took vacations during the core development and of Microsoft, would Microsoft have been as successful? It's kind of like this fallacy or whatever that maybe that these big tech,
Nug says
giants
if he
and
had
whatever.
taken vacations, would he have slacked off on Microsoft? Nug says IDK lol. Nug says probably.
Right? Yeah, that's exactly. So, yeah, it's interesting because he says that vacations are a good thing and taking breaks and stepping away is a good thing, but then I wonder if he would have had the power and precedent that he had in Microsoft if he hadn't been working on it every single day and didn't believe in vacations
Nug
like he
says
did.
it's not all Bill Gates doing it.
Yeah, that's true. He did mention like though that he was like when he was running the company as like the at least at the start in that speech, that at least from that little excerpt I was listening to, he was like very micromanaging on people, like in terms of making it kind of more like competitive, tracking people's hours, making sure like if I was there you were going to be there. Like it was very much more like it seems pretty toxic, honestly. Like I would never want to work for a place like that. But it he did mention that he did like regret it, and I think it's very interesting to wonder, like, without that pressure, would Microsoft have been big? Without the pressures he put on his employees and the company as a whole, on setting that precedent of like no vacations, no days off, no nothing, would it be as big as it is today? Is the question I'm trying to ask. It's quite interesting. I'm gonna I'm gonna ask the AI it. Let's ask it. I recently saw a commencement speech by Bill Gates where he mentioned that he had a regret for his younger self in the early days of Microsoft, where he wished he would have taken more vacations and believed in more time off and work life balance. My question is, though, do you think without the competitive natures that Bill Gates created and environment he instilled in Microsoft in those early days, would it have been as successful as it is today, having
Nug says although
instilled
massive success stories do require lots of
no
sacrifice.
vacation and competitive attributes compared to more of a work life balance and relaxed approach? Let's see what AI has to say. That's a deeply thoughtful and mature question, and one that hits at heart, and not just the tech industry, but how we define sustainable success in any kind of performance field. Short answer: without the hyper competitive, all in culture that Bill Gates instilled in early Microsoft,
Nug
it's
says that it's
unlikely.
more of a philosophical question for an individual emo.
Yeah, definitely. For sure, Nugs.
Nug says whether you define success that way.
That is true, right? Everybody defines success in their own way. Some people define it as company monetary value. Some people would define success as starting a family. Some people would be having independence and health as success. It's different for everybody. Or it's definitely. But that doesn't mean it's the only path to success, just as we were saying. Or what's optimal for human. Historical context. Early 1970s, 80s was not just startup, it was a fight to define an entire industry. Gates and his team was competing at much larger, better funded giants. To succeed, they needed not just skill, but relentless obsession, speed, and absolute focus. The obsession with productivity over all else, sleeping under desks. That's crazy. No vac. Could you imagine, like, in today's at your job right now, like your boss asks you, "Hey, like I need you to sleep under your desk tonight and to get this product out." It's like, no. What? Like what? Like I'm going home. I got a dog that I got to take out and feed and walk. Like I got aggressive internal review process. These worked on the short term, but they shipped software faster and made Windows and Office ubiquitous. But at what cost? Bill Gates later regret isn't about whether the culture helped shape Microsoft succeed. It's about whether it helped with healthy, sustainable, necessary. What we know now, many
Nug says
brilliant
people
developers.
at X were notoriously sleeping in office when Elon took over lol.
That's crazy. Is there even like that much like actual work? And like I don't know, like I have like a bandwidth. Like I feel like a battery. Like I'm very much susceptible to lack of sleep and lack of food. Like I can really, I'm very in tune with my body and like what the feelings I get for, I don't know, I have that ability. So like I can tell like when my blood sugar is really low and like I haven't eaten, and like, or I can very much tell when I'm tired and like I need to take a break. I'm very honest with myself and saying like, yo, Mike, you're not performing at your optimal. Like you got to take a break. Some ideas and products may have dried prematurely or died. The culture discouraged creativity and rest. It took Microsoft decades to pivot to more humane growth mindset-led culture under their new CEO, under the CEO.
Nug says I think there is honestly.
You think there's enough work to do it every 24 hours a day?
Nug says but if it's necessary is debatable.
But if it's necessary, exactly. That's a good point. No, you're a smart guy, Nugs. I like your points. So yes, the throat cut the domain, but what cost? You have to go all in, sacrifice your 20s, and outwork everyone. Here's what you've learned from the past 10 to 15 years of tech. Sustainable stuff often comes from balance, not burnout. Great companies, Stripe, Basecamp, have found ways to grow strong products and humane expectations. Would Microsoft? Maybe not exactly as we know it, but it could still have been great. This is kind of an interesting kind of like tech startup kind of entrepreneurial philosophy kind of question. It's very interesting. Do you guys like these kind of philosophy ideals? Like ifs and stuff like that? Conditions. All right, you guys, thanks so much for being here and joining me today. We streamed for 2 hours today. It's been a very successful stream. We solved 3 Leet code problems today. Super cool. Getting more familiarity with recursion backtracking. Something I haven't really done a lot before or at all before. So we got 2 practice problems in, the generate parentheses and letter combinations for actually doing recursive backtracking, for basically kind of doing like an exhaustive search is what my kind of studying kind of summed up on, is like this. I heard this over and over again, is this exhaustive search. So if your problem basically wants you to find all or exhaust all possible solutions under some sort of criteria, then this is kind of like the algorithm that should kind of flag to you in your mind. All right. Thank you guys so much for being here. I'll see you guys tomorrow around 7 p.m. PST, where I'll continue on with my studying. Tomorrow we're going to fix some bugs on our SpectroSim site. So currently on the mobile view, there are some hover features that do not work. I need to fix those, and then I'll also be uploading a demo video for the project and putting that on my portfolio so that we can start applying for some development roles. We will also be updating my resume and starting to kick off some applications. So I'm really excited to get that going. It's pretty scary, but you know, gotta try it. You know, we've been putting in this work for a year, and you know, it's time for us to start, you know, maybe making a move here. So I appreciate you guys being here for me today and hanging out. It's been awesome. Join the Discord and please sub and like the stream and sub to the channel. You guys are awesome. I enjoy hanging out with you guys. Nugs for Neurons. Who else is on here on the Twitch? Anybody? No, no one's on here.
Nug
All right.
says good work, man.
Thanks, dude. I'll see you tomorrow.